it gives you x to the 2/3. So I'm just putting this note so that you guys see where it's coming from. So I'm gonna change that to this 1/3, and then I'm gonna put the 2 outside, and then everything else stays the same. Okay, so now it's a quadratic equation because you have the 2 and then this and then the constants. Before we can move on, I'm gonna equal that in a statement. I'm gonna equal this because we don't want to work with this. So I'm gonna equal the x to the 1/3. I'm gonna equal it to y. Just choose any letter that you like as long as it's not the same one that you have here originally. So x to the 1/3 it's equal to y. I'm doing this to simplify the math, like I said when I was doing the notes for this section. So instead of using these things, I'm gonna substitute them for y. So now I'm gonna have y squared minus 6y plus 5 equals 0. So now it looks much easier. Remember, we're solving for the x, but before we solve for the x, we need to solve for this y that we substituted. So how do we solve for anything? We factor, or we use quadratic formula, whatever you like, but factoring for this one would be the easiest way. We're using a y because we substituted for the x. Two numbers that multiply to this and add to this would be 5 and 1. They have to be negative, so both of them will be negative. Equals 0. Okay, now we have it, so we're going to split them. So y minus 5 equals 0 and y minus 1 equals 0. So that means y is equal to positive 5 and y is equal to positive 1. So from here, we need to go back to the original statement, and we need to resubstitute the x to the 1/3 for the y, because we already simplified it enough that we can work with this. It's already simplified enough, so we're gonna use this now. Now it's much easier to find the answer using that x to the 1/3. So anyone, I know you know this Miller, besides Miller, how can we, because he was here with me yesterday, he knows. How can we get rid of that 1/3? What do we need to do to both sides of this equation and this equation to get rid of that fraction, because we want to solve for x? Sophia or Al? No? Cube it. So Al was right. We're gonna, so this 1/3 means cube root. So we're gonna cube both sides. If you don't know how that looks, you could have done this. 1/3, so I'm gonna show you another way here really quick. 1/3 means cube root of x equals 5. And this one is cube root of x equals 1. So it's the same thing. I'm just showing you when you use a radical, you guys can see right away that you need to cube. So when you cube this part, this cancels out. So you have x 5 to the 3rd. This cancels out. You have x 1 to the 3rd. 5 to the 3rd would be 5 times 5 times 5, which is 125. 1 to the 3rd is just 1. So these are the answers. Same way with this. These two are the same thing, they just look different. You would have 3 over 3 equals 5 to the 3rd. 3 over 3 equals 1 to the 3rd. 3 over 3 is 1. 3 over 3 is 1x. This is 125, and this is 1. Two different ways, the same thing. So those are the answers. Okay, I'm gonna try to go faster. 6. I think I gave you guys 6 during the test. Should I do it again, Miss Benitez? Because I gave it to them. No, this one is long.
I would give it 10.
Okay. Okay, so for this one, we're gonna use the difference of cubes. Formula, or is a cubed minus b cubed equals a minus b, a squared, a times b plus b squared. We're gonna use this one. I can see right away. So before we can do anything, we're gonna have to bring this one over to this side. And this one was a hard question. It was kind of hard. So now I have it. So I'm gonna copy this here, down here, so that you guys see what I mean with difference of cubes. So I need to make this look like this in order to factor this stuff. So we know this is already the same. So a cubed, we have x cubed. So that one, this part is already done. Minus and minus, so that's good. That one's already done. These two do not look the same. We have a 27 here. This formula has a b to the cube. So we need to make this 27 look like something raised to the cube. So this is where your skills come in, and then you need to remember the perfect cubes. So 27 can be rewritten as 3 to the third power. 3 to the third power, so let me write it here. 3 to the third power is equal to 27. 3 times 3, 9 times 3, 27. So I made them now look like this as a difference of cubes. Now I know my A is x, and my B is 3. Now I can use this formula. So what's A? X minus what B? 3. What's A? X squared plus what's A again? X. What's B? Times 3 plus B. What's B? 3 squared. So now I have, actually I'm going to take this out. So now I have that x minus 3, and then x squared plus, I'm going to switch this one's 3x plus 9. It's equal to what originally? 0. This is what I have so far. This part can be solved. So remember, you split them. So x minus 3, you split the factors, equals to 0. X squared plus 3x plus 9 is equal to 0. This one, you know the answer would be positive 3. This is one of the answers. This one is, it's again, it's a quadratic equation. We can do this yet. We're gonna have to again either factor or use the quadratic formula. And I can tell you right now, we cannot factor this. So we're gonna have to use the quadratic formula. So let me write it here. This was a long question. I should have. So now identify the A. The B is 3, A is 1, and C is 9. So using the quadratic formula, remember it's negative B, which is 3, plus minus square root of 3 squared minus 4 times A times C over 2 times 1. So let's keep solving it. So 3 squared is 9, and 4 times 9 is negative 36 over 2. So negative 3 plus minus negative 27 over 2. We have a negative, so remember what happens. You need to take it out as an I. So I square root of 27 over 2. These are the other two answers. So this and this. Remember, this is two answers because of the plus and minus.
You won't have to simplify the 27?
Oh, yes. Where did I? Yes, you can. Thank you, Ms. Benavides. So this one can be further simplified. I didn't see that. So 27 can be split into 9 times 3 over 2. So negative 3. I didn't do that yesterday. I forgot. So square root of 9 would be 3. I square root of 3 over 2. And I will leave it here, even though you can factor a 3, it won't make a difference. So this is the actual answer, sorry. This one and this one. So 4 more and we're done. You guys can leave until I'm done. Hopefully you guys submit this. So 7 and 8. So solve inequality for x, write solution set in interval notation. So now we're solving for an inequality. We're gonna have a number line. We're gonna check for regions. So the same way you solve equations, you do with inequalities. So here you need to be conscious that you need to find a number that can divide each term. Sometimes that happens. In this case, it is one of those instances where you can divide by that leading coefficient or something where everything is going to reduce, simplify. So this is going to simplify to x squared. This is going to simplify to 25 less than or equal to 0, right? 0 divided by 2 is still 0. So remember, this question like this hasn't come up, but you always have to check if something divides every number in the equation or inequality. So now, again, we're back to difference of, in this case, of squares now. Difference of squares, because we're going to have to factor to solve for x. We're solving for x again. Difference of squares looks like this. A plus b, and we've done this one so many times. This one we have used a lot. This is the formula. So we have a squared minus b squared equals, I'm going to put equals even though we have an inequality. Like that. So we're going to simplify that. So these two look the same like the other one, x squared, a squared. So that one's done. Negative, that one's done. These two do not look the same. We need to convert this into something that looks like this, and that's 5 squared. So now we have everything. A is equal to x and b is equal to 5. So now we can factor it. What's a? X plus what's b? 5. What's a again? X minus what's b? 5. So these are the factors of this. So now let's rewrite it. And then we have a 0 on this side. So how do we solve again? Very repetitive. You do that. Instead of an equal sign, now we have the inequality, but it's the same. So subtract 5. So x is less than or equal to negative 5. Add 5. So x is less than or equal to positive 5. If you guys remember this is where we check the regions. So we're going to draw a number line, right? It's an inequality. How are the regions divided? By these numbers that you just found. So we're going to put 0 in the middle. I'm going to put negative 5 here, positive 5 here. I'm going to draw a line through it like that. So this question has region A, B, and C. It has three regions divided by those numbers that we found. This one says that the solutions are here. This one says that the solutions are here. But we don't know where they are exactly, so we need to check where they are. How do we check? We're gonna use a number in each of the intervals. I'm gonna use 0. It's always good to use 0, so I'm gonna equal x to 0 in this region. I'm gonna use 6 on this side, so I'm gonna equal x to 6. And I'm gonna use negative 6 on this side, so I'm gonna equal x to negative 6. Now let's check the regions using this inequality. Do not use this one. That one's already simplified for you. Might as well use this one. So we're gonna substitute into this formula, into this inequality. So negative 6 plus 5, negative 6 minus 5 has to be less than or equal to 0. This gives me negative 1. This one gives me negative 11. Negative 1 times negative 11 gives me positive 11 is less than or equal to 0. So who's there? Sophia, is this a true statement or a false one? False. False. 11 is not less than 0. So this is not part of the solution. Even though it says here that it was, we check and it's not the solution. So that was not the solution. I'm sure if we check that one, I'm gonna do it quick. So I'm sure this is not gonna be the solution. So 6 plus 5, in this case is a positive 6. 6 minus 5 less than or equal to 0. This is 11. This is 1. We get the same 11 less than or equal to 0. So again, this is false. This is not part of the solution. But it wasn't indicated that it would be, right? Based on that direction of these things, we knew this one wasn't going to be. Now let's check the middle one. So x equals 0. Let's check this region. So 0 plus 5. 0 minus 5 has to be less than or equal to 0. This gives you 5. This gives you negative 5. 5 times negative 5 gives you negative 25. Is negative 25 less than or equal to 0? Yes, so this is a true statement. So that means the solution lies in the middle here. Okay, they want us to write it in interval notation. We're almost done. When, and I forgot to mention this from the beginning. Where should I write it? Let me write it in pink. When you're using inequalities, if you're using these symbols, the less than or greater than, or if it's going to infinity, so any of these three events, you're gonna use parentheses for the interval notation. This is the interval notation. If you have the line at the bottom, the less than or equal or greater than or equal, you're gonna use brackets. I explained this before. So are we using brackets or parentheses for this one? Look at the original equation. Are we using brackets or parentheses? Look, it has the equal sign. So we're using brackets. So these are brackets here. This bracket is not facing this way. It was actually, we proved that it's facing that way. So the interval notation would be brackets, negative 5, comma, positive 5. That's the solution for this in interval notation, and this is the solution graphically. Was that hard, Ms. Benavides? Yeah. It is?
I think so. There's a lot to remember.
Okay, we are almost done. Ooh. I'm gonna speed up with this one. It's taking too long. So this one is again the same, but now it's a fraction here. So we need to find these two values that I found here. I need to find the numbers that divide the regions. When you see a fraction, it's actually easier than the other one. To find the those numbers, the first thing you need to think is what numbers makes the denominator a zero, because remember, denominators cannot be zero because that would make it the fraction undefined. So what number makes this denominator a zero? If you don't know, well, you can always do this also. You can always equal that to the zero, or I mean, you can always like put these two together, and that solving it would tell you what number makes this a zero. So when x is less than 6, or when x is 6, in other words, this would become a 0, right? 6 minus 6 would be a 0. So that's one of the numbers that divides the region. The other number is solving for this thing. And it's really easy to solve because of that 0. So we're solving for x. We need to get rid of this. So that means you're multiplying by this whole thing, because we want to get rid of it. On this side, it cancels out. You're left with this. This times 0, it's always 0. Then plus 5. So x is less than positive 5. So we found the two numbers that divide our regions. So it's actually easier. I think this one is easier than the other one. So 0 is over here. I'm going to make a big space because I'm going to make 5 because that's one of our numbers that divides it. And I'm going to put 6 way over here. It's not to scale, but you'll see why. If I put it to scale, I won't have enough space to work. So this 0 maybe should be like way over here. Way over here. So these are the region A, region B, and region C. I'm going to use 0 from this one because 0 is over here. From here, I'm going to use 5.5. And from here, I'm going to use 7. I'm going to check each region. So I'm going to use this. So 0 minus 5, 0 minus 6 less than 0. So this becomes negative 5 over negative 6 less than 0. So negative over a negative becomes a positive. It's 5 over 6 less than 0. Sophia again, sorry. No? Okay, so false. So this is false. Should have given us true. I was hoping it would give us true. Alright. So let me see this one on this side. 7 minus 5. Did I make a mistake, Ms. Benavides?
I don't think so.
I feel like I'm making a mistake. I don't know. So 7 minus 5 is a 2. 7 minus 6 is a 1. So this is a 2 less than 0. False again. So this is not the solution. Let's try this one. 5.5 minus 5. 5.5 minus 6. 5.5 minus 5 gives me 0.5 positive. 5.5 minus 6 gives me negative 0.5, right? What's 0.5 divided by 0.5? I don't know that. Negative 1. Oh, yeah. My brain didn't work right there. It's 1. It's the same thing. But with the negatives. So is negative 1 less than 0? Yes. So again, this is the solution. What do we use here? Brackets or parentheses? L. Do we use brackets or parentheses when you don't have the line at the bottom? No, parentheses. You use parentheses when they're not equal. So you would have parentheses 5, comma 6. And that's the interval notation of this thing. That wasn't that hard, no? Kinda?
So for me, interval notation is something new.
Uh,
I don't know about that.
we covered. I think you were absent that day.
Absent 'cause I'm not reading.
Yeah, you were absent. And it was only one section. Oh, I have 2 more to do. They're graphing. Okay, let me do the easy one. I'm gonna do the last one. Okay, 2 more, guys. I'm gonna try to do this one really quick. So we need to graph, find the vertex, and the intercepts. So we need the vertex, we need the x-intercept, and we need the y-intercept.
Mister,
Yes.
could you go back to 9? I didn't finish copying it down.
All right. 8. It was 8. Sorry, guys. This is 8. You can't see the number. I'll be back in a minute.
Take a break.
Then I'll have to edit the video for Aliyah. Okay, sorry guys, I'm almost done. Sorry. Let's do this really quick. So we need to find these 3 things. So I'm gonna use the vertex formula, which is this. So vertex is negative b over 2a, and then you substitute in the function, like that. So this is the x and the y, or is the h and the k of the vertex. So let's find, we only need b and a from this. So we know a is equal to 1, and we know b is equal to 10. That's it. We don't need anything else. So the x value or the h value of the vertex would be negative 10 over 2 times 1. So this is, I'm gonna name it h. This is the h. So this would be negative 10 over 2, which is negative 5. So the h is equal to negative 5. Now let's find, so I forgot this is find h. Now we're gonna find k. So how do we find k? Well, we need to substitute this h into the original equation, into that function. So what's k? What's h is equal to negative 5? Substituting to that x. So it's like this. So negative 5 squared plus 10 times negative 5 plus 25. This gives me positive 25. 10 times negative 5 gives me negative 50 plus 25. So it's going to give me 0, right? Plus negative 50. 50 plus negative 50, or you can rewrite it as 50 minus 50. Gives me 0. So the k is equal to that. Did I do it right, Miss Ben? Check my work. So the vertex, we found the vertex. Let me put it over here. The vertex is negative 5, 0, based on what I found here. Now, what do we need? The y-intercept. The y-intercept is given to you. It's this one. And it's really big. So when you find the y-intercept, the x is 0, and it's this number, 25. Wow, that's so ugly. How am I going to graph that? Now, we need to find the x-intercepts. So when you're trying to find the x-intercept, y would be equal 0, the opposite. So you're going to look here in this equation, what's the y? The f of x is the y. So you're going to make that a 0, and then you have this. This is what we've been doing all these weeks. How do you solve this one again? You factor. We're using an x. That one's a 5 times 5 gives you 25, and they add to 10. Oh, this is one of those beautiful ones. Yeah. So you're only gonna have one x intercepts. Because, well, if you split them, let's not get into complicated stuff. If you split them, you're gonna get the same x. So in reality, we only have one x intercept, which is negative 5, 0. So the opposite of the y-intercept, right? 0 for this. Now for this one, 0 is over here. So we found all the points that we need to sketch the graph, and now I'm gonna really sketch this thing, because so I'm gonna sketch. So it touches at 5, negative 5. So 1, 2, 3, 4, 5. So let's say this is negative 5, 0. That's the x-intercept. And then it touches the y-intercept at 0. So somewhere over here, 25. Let's pretend this is 25 because there's not enough space. And let's pretend this is negative 5, 0. And the vertex would be this again. So the graph would look like this. That's it. I don't have space over here, so I can't. So that's the sketch. This is really a really ugly sketch, but it is. So the last one. You want to do this for? I'm tired.
Getting tired?
Yeah. Okay, sketch again. Good thing for this one, the vertex is given to us, because this is in vertex form, guys. Vertex form looks like this: x minus h squared plus k. This is the original equation. So the vertex, when they're giving you this equation, would be the h and the k. So that means this is the h, and that's the k. So the vertex, you already have it. It's always the opposite. You see how that's a negative, but the vertex is positive. So you always do the opposite of this sign. So positive 4, comma, negative 2. That one stays the same. If it's a negative, it's a negative. So that's the vertex. We found the vertex. Axis of symmetry. Axis of symmetry. It's always the h. So this is denoted by x equals h. Remember, this is the h. This is the k. So the axis of symmetry for this equation would be x equals 4. This is the axis of symmetry. That's the vertex. Okay, to sketch it, we need to do the table, and I didn't want to do that. I'm tired, but I'm going to do it because I promised. So what's the function? So I'm going to pick, what do you think we should pick, Miss Benavides? 0 maybe?
Well, gosh, our x is, the vertex is at 4.
4, so maybe like,
So 2,
oh yeah, you're right.
3, 4, 5, 6. Maybe?
2. So I'm going to get rid of that 0, 3, 4, 5, and 6. Well, we know 4 is what? 4 would be equal to what? Negative 2, because that's a vertex. So let's solve for this one. So you're going to put 2 in here for the x. 2 minus 4 squared minus 2. So 2 minus 4 gives you negative 2 squared minus 2. Negative 2 squared gives you 4 minus 2 equals 2. So 2, 2. And 4, so let me put it over here. 2, 2, that's what it gave me. And this one is 4, negative 2. Alright. Let's do 3. 3 minus 4 squared minus 2. That is negative 1. Square minus 2, that's 1 minus 2, which equals, wow, negative 1. So this gives me 3, negative 1. And since they're symmetrical, I know this is going to give me the same, no? 5,
It should.
negative 1. And since this is symmetrical, this is going to give me 6, positive 2.
3, negative 1. And 2, 2.
So 6, 2, right? And 5, negative 1.
Yeah.
Because they're symmetrical, if you substitute, you will get a negative 1. If you substitute the 6, you will get a 2. Alright. So let me sketch it. A true sketch. So let's find the vertex. Negative, positive 4. 1, 2, 3, 4. Negative 2, so around here. This is 4, negative 2. Let's find this point. 2, 2, so 1, 2, and then 1, 2. Around here, this is 2, 2. 3, negative 1. 1, 2, 3, negative 1.
That's why I thought that one was weird.
Right here, negative 1. Really close to the other point. And then 5, negative 1 here. And then 6, positive 2. So that would be the sketch. So this is 3, negative 1. This is 5, negative 1, and 6, 2. The axis of symmetry is a line that cuts the graph in half, and that's x equals 4. This is a vertex. This number right here. That's it, guys. Wow. You guys turn it in. You guys can go now. Thank you for staying here with me.